day, sir. This project is called Numerical Solver, a Python-based graphical application designed for solving numerical methods and matrix algebra problems. The system was developed using Python tkinter for the graphical user interface, NumPy for mathematical computations, and matplotlib for graph visualization. In this presentation, I will focus on the front end or user interface of the system and demonstrate how users interact with the application. The application starts, the user is presented with a clean and organized graphical interface. At the top, we have the system header displaying the title Numerical Solver. Below the header is a tabbed interface that separates the program into two main functionalities, root finding and matrix operations. This layout makes the application easier to navigate and more user-friendly. On the root finding tab, users can enter any mathematical equation into the equation input field. The system supports expressions such as polynomials, trigonometric functions, logarithmic functions, exponential functions. For example, x cubed minus x minus 2. The application provides multiple numerical methods for solving roots of equations. The user can choose from incremental method, bisection method, regular falsi method, Newton-Raphson method, and secant method. Using drop-down menu improves usability because users can quickly switch between methods. The interface also allows users to input numerical parameters required by the selected method. This includes lower and upper interval values, tolerance value, and maximum number of iterations. The interface dynamically changes depending on the selected method. For example, Newton-Raphson only requires an initial guess, while bisection requires interval bounds. Once all parameters are entered, the user simply clicks the Solve button. The system then processes the equation and displays iteration results, graphical visualization, and approximate root value. On the left side of the interface, the application displays an iteration table. This table shows the step-by-step computations performed by the numerical method. Depending on the selected method, the table may display iteration number, interval values, function evaluations, errors, and approximated roots. Color highlighting is also used to improve readability and help users identify important iterations. On the right side, the application generates real-time graph of the mathematical function. The graph visually shows the curve of the equation, the x-axis, approximation points, root estimates, iteration movements depending on the numerical method. This visualization helps users better understand how numerical methods converge toward the root. For the linear equation, we used 2x minus 4. This is for the incremental method. This is for the bisection method, regular falsi method, Newton-Raphson method, and secant method. And for the binomial equation, we use x squared minus 9. This is for the incremental method, bisection method, regular falsi method, Newton-Raphson method, and lastly, second method. These equations were entered in the equation input field before selecting the numerical method and solving the problem. This ensures that the system demonstrates how different numerical method works using both simple linear and binomial equations. The second tab is dedicated to matrix operations. This section allows users to perform various matrix computations using an interactive grid interface. Users can input matrix values directly into editable matrix grids. The system supports operations such as matrix addition, multiplication, transpose, determinant, inverse, adjoint, matrix powers, and solving linear equations. Users select operations through a drop-down menu, making the interface simple and organized. After clicking the Calculate button, results are displayed in the result panel below. The output is formatted clearly for better readability. In conclusion, Numeric Lab Solver provides a user-friendly graphical interface for solving numerical methods and matrix algebra problems. The front-end design focuses on accessibility, visualization, organization, and ease of interaction. By combining computation with a graphical visualization, the system helps users better understand mathematical concepts and numerical analysis techniques. Thank you.